Hello everyone. Welcome to this joint demonstration by Keysight and Synopsys. We are going to show you how seamless integration between Synopsys Custom Design Platform and Keysight PathWave Advanced Design System ADS platform is enabling the designers to meet complex design requirements for next generation of RF systems. We have Cedric Pujol, Product Manager of Keysight Technologies, and Damian Roberts, Senior Staff Application Engineer of Synopsys, to walk us through the flow with a live demo on this integration. Keysight and Synopsys have jointly developed a unified solution for a full flow RF design. Our best-in-class tools in both platforms are talking to each other in a seamless fashion and deliver faster layout and design closure. This close collaboration is helping the designers to achieve complex RF design requirements and delivering their products to market much faster. Here is the high-level overview of the demonstration. Cedric and Damian will show how you can create the custom layout of the RF elements with proven productive features of Synopsys Custom Compiler. Here we are taking the example of an inductor coil in reference 40 nanometer technology node. Then we will take that layout and run full flow electromagnetic analysis in Keysight RF Pro. And then we will check the characteristics of this inductor coil with many result analysis features in Keysight's ADS platform and generate a sub-circuit model of the optimized inductor coil. After that, we will bring this inductor model as a symbol in Custom Compiler and build a test RLC circuit to see the response with transient and AC analysis using Custom Compiler built-in simulation environment and waveform viewing and debugging capabilities. Let's enjoy the tools in action. Go ahead, Damian and Cedric.
Thank you, Sonny, for the introduction. So here we are in Custom Compiler Library Manager. So first thing we're going to do is come down to the library that has this inductor design in it and open up the layout for that inductor. So here we have the inductor drawn within the layout Custom Compiler. The first pins here, you can see it spirals round. There's a center tap here, spirals back round to the second pin over here. Okay, so the first thing we're going to do is turn on the RF Pro integration menu within Custom Compiler. That gives us an additional menu up at the top here. And then we're going to go in and define our substrate appropriately. RF Pro can use the standard ITF file that you would use to generate an NXT-GRD for star, as well as other file formats, to generate its own LTD file of the layer stack. So here's the layer stack defined for this process. So I'm going to just close that now and actually start a new view for RF Pro. To launch the RF Pro tool, and then pass over to you, Cedric.
Thanks, Damian. So let's simulate this coil in RF Pro then using an electromagnetic solver. So the first step that RF Pro will do is read the open access database that is coming from Custom Compiler and produce a 3D view out of the substrate and the layout that has been found. So when I say it reads the open access database, you can find the nets that you have in Custom Compiler, you can find the pins, and if you have components as well, you can also find them here and select what needs to be simulated at EM level or at circuit level. So to do this analysis of this coil, you need ports to excite the structure in EM. So you will take the pins that are here and drag and drop them onto the port section. And then the reference of the port will be either found on the layout to closest pin that belongs to the ground or to the substrate, as in this case. So if you look at the ports, the 3 ports are highlighted here. The next step is to be able to select a frequency plan. So this coil goes quite high in frequency. So we will go up to 40 gigahertz and then you need to choose a simulator, either planar with momentum for ICs, and if you have some 3D effects, you can use the full finite element methods as well there. So let's use momentum for this coil. Once it's done, you double click on run, and that will launch momentum on this simulation, on this coil, and then the simulation will take around 15 seconds to be completed. Once it's done, the next step is, of course, to look at the results, and we can look at the results like S parameters directly inside RF flows. Let me maximize that, and we will go looking at the S parameters between the inputs, so 1 and 3, to the outputs. So I'll take the 1, 3, and then you get the S parameters. But for coils, you have also predefined built-in measurements like the quality factor. And if I click on that, you will get the quality factor and check that this inductor peaks around 16 gigahertz. But more generally, what you want to do is to go back to circuit simulation to insert this coil into a larger test bench. Then what you can do is double click on that generate subcircuit button and create a view. And RFO will create a schematic out of the S parameter box that he has. Here it's only a coil, but remember I said when you have components that you can't simulate with an EM solver, like active components, then they will be automatically rewired for further simulation if you have transistors or blocks that you can't simulate with an EM solver. And then that's done with RFO, and I will hand over the next part to Damian.
Thank you, Cedric. That's great. So here we are back in Custom Compiler. So this is the subcircuit model that RF Pro has created and exported back into the open access database here. Just to illustrate, the endport model here is using a City touchstone S parameter model to actually capture the frequency characteristics of that coil. Okay, and of course, RF Pro has created a symbol for this as well. So we're just going to come back to our library manager then within Custom Compiler, go to the appropriate test bench, and I have a schematic already created here, just waiting to have the appropriate inductor model dropped into it. So let's place that, and then I can drag it into place. Okay, so if we descend into that, we can see that this is the same model we created just a few minutes ago. Okay, so coming back up to the top here now, we'll come across to Custom Compiler again and open up the SAE state for FineSim that I created previously. This has a transient analysis and an AC analysis already set up. FineSim, of course, supports many RF analyses like periodic steady state, harmonic balance, phase noise, etc. We'll just launch our simulation there. Okay, it's asking me to save that because I made an edit adding the symbol to the schematic. So here we are with FineSim running. That was the tran, now the AC, and we're just going to be plotting those results in wave view. So we had expressions already set up within SAE down at the bottom there. And so here is our frequency response created by FineSim, and this is the time domain response of that circuit as well, which is pretty cool because FineSim has done a convolution to take the frequency domain model of the S parameters and turn it into a time domain model. So there we have the full flow from a layout of the coil through to RF Pro, extracting the frequency response of that device back to circuit simulation with FineSim and SAE and Custom Compiler. Okay, back to you then, Sonny.
Thank you so much, Cedric and Damian. That was an excellent demo that clearly showed the value of partnership and close collaboration, not only between Keysight and Synopsys tools, but also between people. As you saw in the demo, this unified flow enables you with a comprehensive design and verification solution to deliver faster layout and design closure. while meeting the complex design requirements and target for time to market. One of our customer, Core Hardware, recently shared how they were able to create full custom RF and analog mixed signal ICs for 5G by using this full custom flow. Please check out the press release on this link below. I hope you liked all the information we shared here. Please check out our websites to learn more. Stay tuned, and thanks for watching.